Right. So moving on to our next speaker, I'm really excited to have this case study with Mark Keith. It's about how AECOM used Unify to ease congestion in Sydney. Learn how distributed data capture helped the client control complex projects in large programs. Unify is a multiple award-winning software business spun out of MBH in 2013. Its core web-based product is a portfolio and project manager software system used mainly in the built environment for both construction and infrastructure projects and businesses. Mark is the founder and sole director of Unify. His role is to provide the direction for future development, sales, marketing activities, as well as direct support to the clients. And during the past 12 months, this means working directly on projects worth over 40 billion pounds, 40 billion Australian dollars. Most current projects are Melbourne Metro, West Sydney Airport, easing Sydney congestion. Welcome, Mark. Let me hand it over to you. Thank you.
Thanks a lot, Phil. Just share my screen. And yeah, thanks a lot for the opportunity to come along and present today. I think the platform that you've got with Glimpse of the Future is fantastic. The concept of bringing new tech into the construction industry and getting awareness across the industry about what's coming up, and the other presenters and the range of stuff that's coming on board is really exciting. For me, having been involved in it for quite some time now, it's really interesting to see the adoption and the way that people are looking at it in greater detail than, say, even 5 years ago. So my topic today is about distributed data capture, excuse me, and how we have this sort of concept, this hypothesis that distributed data capture can, just get my video working, how distributed data capture can manage complexity. And so that's basically the topic of this concept, and in the context of a real life example in the way we supported that Easing Sydney Congestion program. Bit about us first though, and I think Phil's introduction was brilliant. It basically covered that already. So yeah, we had a parent company consultancy that we spun out this product in 2012 and really went live in 2013. So it's been around for a while. It's a web-based platform product. Portfolio and program and project management is its focus, but it distributes the data capture to people who are active team members on projects. We have 9,000 active users logging in every day around 30 countries, but the predominant is Australia and New Zealand. However, we're now looking at and have been focused into these other 30 countries in the last 6 months, in particular the UK. And hence it's a great opportunity to present to you guys today. And as Phil mentioned, the number fluctuates as some come online and some come off, but we've been hovering around $30 to $40 billion of infrastructure spend that we're supporting for the last 4 or 5 years, actually. And obviously we're supporting millions more in building projects around the country. So this specific topic, Easing Sydney Congestion, is an umbrella program with 3 main sub-programs underneath. It's fairly sizable. We're looking at clearways, bus lanes, pinch point relief, and some other collection of programs. The overall spend is about 4.2 billion Australian dollars. And the complexity comes in from the fact that they're all brownfield sites and there's lots of them. So the projects themselves are quite small, but they're quite complex in that you're dealing with an existing infrastructure that you've got to manage. The stakeholders that are around that infrastructure need to be managed. And not only that, the projects themselves weren't known when the program kicked off, and they're still not known in terms of their entirety. So the program is constantly expanding in new projects, and it has a process to identify those and to select them. So the program is emerging over time. And when you have emergence and you have complexity in scope and a lot of issues coming from left field, that's when you have a real ideal scenario for our software. And so what we brought to the table was a distributed data capture model that basically enables people to collaborate every day on the work that they're actually doing. And then from a program and controls perspective, you can just sort of peer in and aggregate and cut and dice. And DJ's sort of presentation around that structure and data structure was quite interesting for me, because that's pretty much what we're coming to the table with. So our emphasis in this example is activity-based support, supporting people to do activities that potentially weren't known about when the project started, or at least what you need to do. The steps are pretty well defined, but what you're going to encounter when you go through those steps is completely unknown. And so we need to be able to share, you know, if there's a utilities issue on a brownfield site, or something that particularly throws a curveball at you on what is a basic activity normally if it was greenfield. And the implications of getting all of that data into the system is that we can then start to use analytics and AI to potentially give earlier warnings to senior management and to the senior stakeholders in government to be aware of certain issues and how they can be addressed earlier than we normally would. And so to put that in a graphical context, this diagram shows how Unify will allow direct data entry from various stakeholders. Up the top here, we've got people who are like designing drawings and managing projects and coming up with new specifications, a new scope of works, etc. Then we've got people in the field capturing directly into the application as well through mobile apps and through other web application type direct data entries on tablets. Then we'll also pull data from other systems that are being used, which could be email, it could be schedules, it could be estimates, and pull that data into our application as well as a REST API, dynamically, basically, without any extraction and cleaning and transforming and massaging and basically worrying about where that audit trail is. We want complete audit trail back to source. And if we get these three sections around the right here, successful and we get all that data, that's what we want as much data as we can get. You can then get the geeks to get on board and analyze all that data in interesting ways, and then ultimately we can develop algorithms that will machine learn. And the thing about machine learning is that it'll end up telling you things that you didn't know without you actually knowing how it did it. So even though you've written the algorithm and you've taught the computer how to teach itself, it will then find patterns within data and will spring up things that you never knew existed. Now, that's still a work in progress for us at the moment, but that's where we're going. Oh, I've gone too far there. So now what I want to do is just show you a little bit about the product itself. And while I'm doing my first bit, I'll just do a bit of that to wake everything back up again. And so this is our application. And what you're looking at here is a subset portfolio within that application, a couple of projects, and they've got their children projects, which in this Easing Sydney Congestion was done as stage gates. And you can kind of see how that gets represented in this drop-down list here. So I'm accessing this through Chrome. You can access it on any web browser, and hence the distributed data, access anywhere kind of concept. And so with this structure here, you can see there's two projects in the list, and each project has a stage gating a sub-project, if you like, that they need to work through to get to the next stage. And as I mentioned in the PowerPoint, what we wanted to do is capture the real everyday task information. And you'll see on the sub-nav here, there's a tasks section. And when I go to that section, you'll see there's different types of tasks. Now, some of these are standard, and they cookie-cutted this approach and developed a really robust process for going through each stage gate. And they're the standard tasks. And each standard task, like this drainage design, has a bunch of subtasks associated with it. And then you'll have issues as well. And the good thing about this is that when you log these things, the interface is the same. And so and you'll see within here, we've got people assigned to them, they've got due dates, and if they log in, they'll get their work and what they need to do and by when. And if they click on these particular activities, all of the sub-activities are listed there. You get a whole heap of metadata around this particular activity as well. That's data that describes data. And in this particular instance, as it's a design document, we've got conversations going on here, but we've also got a link to the actual latest revision of the drawing. So it's, again, about that managing of data and structuring data so that you can access it quickly. That 1 day a week is what we're really trying to crunch down in terms of finding information. And so that's an example of a standard task. And then we've got an issue. We've got an early warning due to possible cultural items, probably something more relevant to Australian listeners than the UK perhaps, but there's a little bit of a gag in here if you can get it. And so this one, we've copied sort of NEC. They weren't using NEC on this project, but you can use NEC, early warning, tracking in this application and align the whole system to an NEC contract. You've got actions again with different people participating. We have site photos taken on board where, as this is a cultural relic thing, we've got toilet paper that was secured in the COVID environment for the future being found on site, and it's now a relic. We've also got deserted streets that represent that. So the system will strip out GPS, which is great for roads programs, and tell you where you took that photo. We've got comments coming in from people randomly directly into the application, but we're also sucking in emails. And so, again, DJ mentioned all the email traffic that is so common. We're trying to reduce that by having conversations here directly, but also understanding that it exists. And you just pull emails in directly from Outlook without needing to manipulate or do anything challenging around that. And you contextualize it to what that email is trying to do. In this instance, the early warning around a possible culture. And we're really promising not to blow up that cultural site. And so that, if you imagine that happening, we've got 200 in AECOM's Easing Sydney Congestion team. The design team was 200 people, 125 full-time equivalents working every day in that program full-time. And you've got all of them piling into here and adding comments and collaborating. And what you get is just a plethora of data. And so this example here, because what we've also got around those activities is timesheets. We've got rates against resources. We've got resource plans. We've got milestones and percentage completes against earned value tracking. And so you put all that in and you start to build aggregate reports. And this was a bit of a classic one for them. This was a report for post-contract work where we were analysing how long it took them to respond to requests for information from a contractor. And so we were able to tell a lot more information than they normally be able to get because of the integration of all of those data points. So we had number of responses they needed, what the total cost was, total hours spent, the cost per issue, the cost per, the hours spent per issue. And this trended over time. And so the red line is costs, the blue is how many were raised, the black is how many were resolved, sorry, other way around. And if I click on those links, and you'll see that the other data updates, and one of them includes a list of the actual issues. So again, it's integrating this data, which I can click on, takes me back into that same sort of environment that we had before with actions, comments. And so long as people are pouring those comments into the system, we should be able to get to the bottom of any of those disputes and what has actually occurred on that job, because everyone's putting that in on the day-to-day basis, including daily diaries and things like that would have things like craneage and how many were on site and who was on site, and various other things like that. And of course, it doesn't end there. This system, once you get it, you can aggregate into all types of reporting. So that we're using Power BI as the visualization tool here, but you've got to understand it plugs directly in. There's no ETL, there's no extraction, transforming, loading, and building this up. And so once you've got that, you can look at integrated progress. We've got S-curves, we've got issues, full-blown dashboards with geolocation around budgets, risks, timelines, how many hours people are spending, safety issues, which again can be drilled back into the specific incident that happened that caused one of those minor injuries to occur. That's showing you there on the screen as 37 in the year. So that type of interaction between the detail and the higher level is really what we're looking for. And then we take it one step further again. And in this particular, sorry, I've just got the Zoom buttons in the road. This one here. This is where we're starting on the AI journey. And so what this has done is, just to simplify for your head how it works, is it strips out all of the comments into single words and then it counts them. And then we haven't stripped out all of the pronouns and everything else, but that's what would happen in the algorithm. And we're looking at words that happen a lot. And so in this example, we've got the word the 109 times. And so from that, we can pattern match to a project that's gone off the rails to one that's performed well, and what words were used in conversation through that activity module to be able to generate the AI elements to this. And so taking that back into my presentation, on this particular case study, in a 12-month period, this is just 12 months, the program is still ongoing, but it's been going for 4 years. You had 339 projects that were initiated or had some progress on them. They had 3 design stages. They had 12 standard steps per design stage, 6 activities, sub-activities. So you would have seen in the activity structure how that worked. And then you had at least an average of 4 comments. So you look at that, and that's 291,000 data points in that schedule, basically. 291,000 discrete data points. However, then you wrap a whole heap of metadata around it, the amount of time spent, who did that time, their role, how that compared to the expected time they were going to have on that project, and that activity. And you end up with 582 million combinations of data that you can analyze, which to a big data person looking at AI, this is the thing. And you look at Tesla, they're teaching cars to drive by collecting data of people driving. We're trying to apply the same thing in projects. Let's get the people who are driving the project to tell us how they're going every day and use that data to see what we can find. And as an example as well, that was 5.8 million words to count individually and categorize and start to tailor. So the implications from a project controls perspective, we can look at how many times date changes, the variations per RFI, benchmarking durations, and have feedback loop into future projects, cost per activity, per other class of metadata. So the usual stuff, but you know that you've got full audit trail back to the source data. But then the extended stuff is in the AI around word pattern matching for early warning, past performance predicting future performance, data cleansing. Are people really just bagging and dumping time, or is it accurate? And we compare that by looking at timesheet data versus task activity and duration. And then obviously also a potential around optimal portfolio selection. So what this means is that new technologies are allowing for live connections to distributed data systems. So not ETL, not having to put it into a spreadsheet first and send it to someone to load into a data warehouse. It's live, it's connected. That gives us deep data sets. We do this by streamlining the collection of activity, by enabling the people doing the work to get benefits out of putting information into our system. And it really does contrast to a closed system where you've got a smaller group of people pouring information into a P6 schedule or something similar. They're getting that data from third parties, and that there's no direct link there. And that's the issue. We need to get it as a living organism, as something that's got everyone on the one platform piling that information in. So if you want to know more, Brian Cairns is our direct agent in the UK. His mobile phone's there, and email, or you can call or email me, or you can check out our software on our website. It has more case studies there and other information about what we've been doing. So yeah, thanks a lot. I saw there's some questions coming in. I'll leave them for the end, I guess, Phil.
That was great. What a tour de force. Data that describes data. That's what it's all about, isn't it? Yeah. I have to tell you, I thought that was absolutely great.